Right, hello, Year 9. Hope you're well. Next lesson, which is the life cycle of a star. Last lesson, if you remember, we looked at the solar system and how the solar system was formed over the 4.5 billion years that it took to form. But hopefully, we had a fairly detailed understanding of the different stages that the formation of the solar system has gone through. Right, today we're going to look at it's a very similar thing. We're going to look at the different stages of a life cycle of a single individual star, and we're going to apply that to all the different stars we can see in the universe. Obviously, our own star is the sun, and that's gone through one version of this life cycle, and we'll find out about that in today's lesson. But anyway, what I'm going to do is just to walk you through this little PowerPoint here, this is one slide from a PowerPoint. Then you're going to get a version of this. You're going to get a version of this to annotate. That's basically your task for today. So let's run through the just like many things, just like humans. Humans have a life cycle, don't they? They're born as newborn babies. They even start as a fetus in the mother's womb, but they will grow into toddlers. Then they'll grow into young children, then teenagers, and then early adult life, middle age, and then old age. There's lots of different characteristics of each stage. But it's exactly the same with stars. There's different parts of our lifetime. But to put it into context, our sun, our sun is in this stage here. Okay, now our sun, I hate to break this to you, but our sun is an average star. Okay, it's not too remarkable. There's quite a lot going on with the whole life cycle itself, but our star is pretty average. It's average mass, average brightness. Now it's in this stage here. This is called the main sequence stage, but we'll come to that in a bit. Anyway, let's start at the beginning. That's the best place to start. All stars start their lives in this stage. This is called the Stellar Nebula. Now, a nebula is a ball of gas. It's like a huge ball or huge volume of low density gas, and it's got bits of dust and rock and maybe bits of ice as well. But they reflect electromagnetic radiation, so they're really beautiful. They give off all these really nice colours depending on what gases are present. Mostly hydrogen. Anyway, gravity will pull that together. Okay, gravity will pull that together. Now, as it gets more dense, friction will heat up the molecules, the atoms, and they will start to get hot. Now, as they get hot, they will start to fuse together to produce heat. Now, that heat will turn the star into the main sequence. Now, the main sequence, that's when the star is balanced. Okay, that's when we've got the huge force of gravity trying to make that star collapse, but we've got all the heat pressure from the nuclear fusion, which is trying to make that star expand. Now, those two forces are balanced. So thankfully, the star stays in that state, in its main sequence stage, for several billion years. And that's where our sun is. Our sun is pretty much maybe halfway through its main sequence stage of several billion years. Anyway, when the nuclear fuel starts to run out, the core of the star will collapse and the outer layers of the star will expand. Now, as they expand, they cool down. And as they cool down, they will start to glow red instead of white. Now, as they glow red, they then enter this stage called the red giant stage. And this is where stars are huge. When our sun eventually becomes a red giant, it will swallow up Mercury, Venus, and maybe Earth as well, if there's any life around to experience that. Anyway, That's the red giant stage. Now, at the end of the red giant stage, when all of the nuclear fuel is finally spent, what's left of the core will collapse in on itself and become very hot and dense, and the rest of the atmosphere will float off into space to produce this planetary nebula, leaving behind the core of what was the red giant. Now, the core is very hot, but nuclear fusion has finished, so it will cool down eventually, become a brown dwarf, and then a black dwarf, and then it's just literally a big lump of iron, actually, because that's the end of fusion, nuclear fusion. Anyway, there's two routes. There's actually three routes, but there's two main routes stars can go. They can go this way, or they can go this way, depending entirely on how big they are, how massive they are. Right, our sun is average, so it will definitely go that route. Now, if for stars that are much, much, much bigger than our sun, they will go this route. Now, the only difference here is the name, really. It's exactly the same. To say the physics is the same, the main sequence is the same, they're just much bigger and hotter, but they're balanced. And when they become a red giant, they actually become a red supergiant. Same sort of thing. The atmosphere floats off, or sorry, expands, cools down, and becomes red. Now, this is the really interesting bit. When the core finally collapses in on itself, the collapse is so violent that it kickstarts fusion a second time, and in such a violent way that the collapsing core explodes. And it explodes as something called a supernova explosion. Now, supernova explosion, supernovae, the plural, are by far the brightest things in the universe. Now, a single supernova from a single star has been known to outshine the entire galaxy it is in. Now, if you remember that galaxies can be 1 to 200 billion stars, that's bright. Anyway, the supernova once will throw out all the debris out into the universe, and it will leave behind a very dense core called a neutron star. Now, that's very different to a white dwarf. It's much, 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 much more dense, super dense. However, there's one final bit. If this massive star was really massive, then after the supernova, it doesn't become a neutron star. It collapses to become something even more dense with an even stronger gravitational field called a black hole. So there you have it. There's the life cycle of a star with a few things on the physics of it. What you need to do now is to, with your version of this, is to annotate it with text boxes from the text that I've given you. Okay. Thank you very much. And thank you very much for listening. See you in the next video.